Okay, welcome back. You should have by now completed the first investigation for waves on a string. You should have been able to calculate wave speed at those 6 specific frequencies. So going back, this data table should be 100% filled in. You've gotten your wavelength in centimeters from the simulation. You've converted that wavelength to meters. And then taking that wavelength in meters, you multiplied that by the frequency we've provided to get your wave speed. So you should have 6 different wave speed calculations completed in meters per second. That's key. Now the second part of the PhET simulation is we're going to look at frequency. Frequency again is measured by counting the number of waves that pass a point over a specific time period. And to make it easier for you, we are going to have you count out 10 waves, and then you're going to time how long that takes. So take a look at this second data table on the screen. This is the second data table that is also provided for you in the packet. There are 4 columns. Starting at the left, this column has the number of times the green dot on the oscillator reaches the top of the wave. Notice we have that pre-filled already for you with 10. That's the number of waves that you are going to be counting out. The second column is time in seconds. This is the time that you are going to be getting from the simulation, and I will show you how to do that using the web version of the simulation. You are going to have to do another calculation, and you are going to get a calculated frequency. Your calculated frequency, I've provided that equation for you at the bottom of the screen. To get your calculated frequency, you are going to take the number of waves, which for each and every calculation is going to be 10. You're going to take 10 waves divided by your time in seconds. That is going to give you your calculated frequency. You are going to compare that calculated frequency to the frequency that is set on the simulation. And we also have given you that information in the data table. So you'll be doing 5 trials. You will set the simulation at that specific frequency, and then you're going to get the time it takes for 10 waves to pass through a specific time period. So I'm going to jump over to the web version, and let's do one example together. So again, this is the PhET simulation, and if you've already cleared the simulation, I'm going to help you get started again, review, make sure you have the same parameters set. So again, make sure you've got that ruler box checked. Bring up that ruler. Make sure that it's set to oscillate. Make sure that you have no end. Have damping set to 0, to none. Have tension set to middle. And like I said, it defaults to 1.5 hertz for your frequency. So we're going to set and leave this frequency the same, and we'll get you started on an example for your second investigation. So for the second investigation, again, you have to count out 10 waves. And we told you to have that green dot on the oscillator at the top of the wave. So you are going to want that green dot there at every trial for the second investigation. Now, it might be hard to get that green dot set at exactly at the top of the wave, but you can do that very easily by pausing the simulation. And then see that tiny blue dot there? That allows you to move the wave stepwise. So notice I can stepwise move and get the green dot at the top of the wave every time. How are we going to get time? To get the time, you want to check the timer box, and that's going to bring up your timer for the simulation. So once you have the timer box up, you have that green dot set at the top of the wave. Once you're ready, all you're going to do is you're going to hit start, And once you're ready with the timer, once it hits the top of the wave, hit the timer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. And you roughly get a time of 6.75 seconds. This would be the time that you are going to put in your timer box with a frequency set at 1.5 hertz. Then to do your quick calculation, you're going to take again the number of waves, 10, divided by your time, 6.75, and then that is going to be your calculated frequency. Hopefully, you're going to find that your calculated frequency is very similar to the frequency set on the simulation. So once you have your first frequency done, you can go back and you can reset the simulation. I'll jump and set that frequency to 1 hertz. Again, make sure that that green dot is at the top of a wave. I'm going to reset that timer because I want it at 0. And then once you're ready, I'm going to get that simulation moving. And then once you're ready, you can click the timer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I got 9.03 seconds with a frequency of 1 hertz. So I would, again, fill that in my data table, keep working through my calculated frequency calculations, and see how close you get to the frequency set on the simulation. So complete all 5 trials, and then what you're going to do is you're going to start wrapping up our PhET simulation, answering these 3 questions. So the first question after you complete your second investigation says, how did your calculated frequencies compare to the frequency that was set on the simulation? Well, I'm hoping you're going to find that they were very similar, hopefully. Okay, there is going to be some room for error, as you can see. The last couple of questions that you have to go through is just making some changes to that PhET simulation. What you're going to do first is you're going to switch the simulation to manual, and then you're going to attempt to try to create some smooth waves. And then answer these questions. Does it seem like the wave speed is the same? And why would that occur? So jumping to the simulation, what you're going to do, I'll stop it, is instead of oscillate, again, you're going to go to manual. So that means using your finger, you're going to have to move and try to create smooth waves if you can, and then answering that question. The last question on your PhET simulation is asking you change from end of the wave from no end to fixed end and see if that can improve the waves that you create. So go from no end to fixed end and now see if that has an impact on the type of waves that you can create. So good questions there, okay? So after you've gone through that second investigation looking at frequency, here brings me to the take-home message. This screen right here, the last part of your PhET simulation packet, is the part that you are going to be submitting into Canvas for your second weekly assignment. For your second weekly assignment, I want you to answer this essential question. What is the relationship between wave frequency and wavelength? So what you're going to do is you're going to fill in this box, which essentially is like a claim statement, a conclusion, based on your understanding of wave speed and the information you've collected from this simulation. I'm not going to show you the claim statement because I want to see what you come up with. So we're giving you a hint. It says, make a claim about the relationship between frequency and wavelength. Is it a direct, an inverse, or no relationship at all? And use the evidence that you've gotten. Now going back, What is a direct relationship? We've had other examples of this in physical science before. A direct relationship, remember, is when you have one variable. If it increases, that second variable is going to increase as well. If you have an inverse relationship, you might have a variable increase and the other variable decreases. So take a look at your frequency and wavelength information that you've collected. What data table are you going to look at? You're going to go back to this first investigation. Look at frequency. Look at wavelength. What relationship do those two variables have? Is it direct or is it inverse? And you're going to fill in this box with again a claim statement. This, science friends, is what you are going to submit into Canvas for your second weekly assignment. You can take a quick picture of your claim statement, or you can file upload in as well. Either is fine. If you ever have trouble submitting anything into Canvas, email me, let me know. I will be more than willing to let you email me a picture of your document as well. So that's all that I have for this second video looking at our waves on a string FET simulation. Complete the second investigation, wrap up answering those conclusion questions, and then answer this essential question: what is the relationship between frequency and wavelength? And then upload your claim statement into Canvas. Good luck, and of course, let me know if you've got any questions at all on waves on a string.